Okay, all of you have seen the laser lights. Laser lights, light amplification by stimulated emission of radiation. আমি ক্লাসে তোমাদের একটা একটা পেন মতো নিয়ে যেতাম, মনে আছে না? হ্যাঁ, যে ওখান থেকে পয়েন্টার লেজার পয়েন্টার, দিস ইজ লেজার লাইট। হ্যাঁ, লেজার লাইট অনেক রকমের কাজে আসে। হ্যাঁ, লেজার লাইট দিয়ে একটা অনেক বড় বড় মোটা মোটা জিনিসকেও কেটে ফেলতে পারে। এত শক্তিশালী লাইট, laser light. So what is this? Laser is very much important for nowadays. It is very much important for nowadays. Now, what is this? First, light amplification. What is amplification? Amplifying the light. Sound amplification. Amplifying the sound. What is amplification? Amplification is, say, for example, sound amplification. If you amplify the sound, you will hear louder. That is sound amplification. What is light amplification? What I call it? You actually amplify the intensity of the light. Intensity of the light. You can amplify the intensity of the light. Lighter tiprata. You can amplify it. So light amplification. Amplification of light means you are amplifying the intensity of the light by stimulated emission of radiation. So this is one new term, stimulated emission. This is a new term. What is stimulated emission? We'll see it now. But we know what is emission. We know what is emission when an electron jumped from the lower state to higher state, when it absorbs the energy, and when it goes down from the higher state to lower state, it emitted radiation. It emits radiation. That is called emission. Emission of radiation. Absorption of radiation means electron absorbs the radiation. That means the electron absorbs the energy of radiation, and it goes from ground state to excited state, higher state, excited state. It goes from ground state to excited state. That is absorption of radiation. And what is emission of radiation? When that electron comes from the higher state to lower state, then it emits radiation. So it is called emission of radiation. So we can understand light amplification and emission of radiation. Now, the main term is stimulated emission. What do you mean by stimulated emission? What is meant by stimulated emission? So if we see here, এই দেখা যাচ্ছে তো না ঠিক মতো? Say, for example, laser. For example, this is ground state. And this is excited state. The electrons are in the ground state of the atom. Say there are 6 electrons in the ground state of the atom. When radiation comes, say for example, its energy E is equal to h nu. Some of the electron absorbs the radiation and moves to the excited state. So that is absorption. Now, when it returns back, it emits energy. It is emission. Now you see, this is a spontaneous process. You will not have to do anything for this emission. You will not have to do anything for this transition. It will come spontaneously from excited state to ground state, and it emit energy in the form of flight, or otherwise it emits energy, and you will not have to do anything for that emission. So it is a small spontaneous process. But it will come down here after some time. Say for example, this electron gains energy and it goes here. It will stay here for some time. For example, it will stay here about 10 to the power minus 12 seconds. It will stay here for some time, about 10 to the power minus 12 seconds. And after 10 to the power minus 12 second, 10 to the power minus 12 second means, I think it is called 1 picosecond. After 10 to the power minus 12 second, after staying 10 to the power minus 12 second in the excited states, the electron will again come back to the ground state by emitting energy, and it is then the whole process is spontaneous process. It will occur spontaneously, and it is occurring spontaneously everywhere. Now, in 1915, around 1915, Einstein, he suggested that there is another type of emission, which he called stimulated emission, So this is spontaneous emission. And Einstein suggested that in 1950 there will be another type of emission, which is stimulated emission. Now, what is that emission? For example, this is ground state. Say here there are 6 electrons, and this is excited state. Say for example, there are 3 electrons. Now, from here, this electron transited to here. From here, from ground state, this electron transited to excited state by absorbing energy, and it will stay here for about 1 picosecond. Say, for example, we call it for 5 seconds, it will stay here. It is very large. 5 seconds is very large. It actually stays about 10 to the power minus 12 seconds. But for sake of simplicity, let us suppose the excited electron will stay in the excited state for 5 seconds. Now, it is staying here for 5 seconds. Now, if another light wave of energy h nu comes here and knocks this electron, pushes this electron, and fell it down to the ground state, then what will happen? It is staying here. Its duration is 5 seconds. But after 3 seconds, for example, after 3 seconds, one energy, one wave of light came here, one radiation came here, and knocks this electron and brings it back to the ground state. Then it will emit energy from excited state to ground state. Is coming from excited state to ground state. Then it will emit energy. Okay. And this type of emission is known as stimulated emission. This type of emission is known as stimulated emission. It is not spontaneous. Somebody pushes the electron, somebody knocks the electron to go to the ground state from the excited state. It is not a spontaneous emission. So in that case, the emission or the wave released, the emission released is known as stimulated emission. So we have two types of emission. One is your spontaneous emission, and another one is stimulated emission. Now, what will happen after the stimulated emission? You see, this wave will knock out this electron to the ground state, and this electron will emit this wave energy, and this wave also accompany with this. This wave also accompany with this wave, with the wave of this, and the frequency and everything of this wave will be equal to this wave. That means the frequency of stimulated emission and everything of this stimulated emission is equal to the energy or equal to the wave that was knocked the electron from the excited state to the ground state. And say, for example, these two again will knock this and this, and you will get same your wave. This is known as amplification of light. This is known as amplification of light. Normally what happens when spontaneously when an electron comes from here to here, it will emit one type of, say, one type of wave. It will emit another type of wave toward this. It will emit another type of wave toward this, through this way. So here you see there is a difference between this spontaneous emission and stimulated emission. What is the difference? These are not coherent. These are coherent. The term, what is the term? Coherent. Coherent means the light of the same frequency, same wavelength, lights are same. This light will form the laser. This light will form the laser. This light of stimulated, this light formed by stimulated emission is the laser. So what is laser? Light amplification. This is the light amplification by stimulated emission. What is stimulated? Emission of radiation. Have you understand? Or did you understand? Light emission, light amplification by stimulated emission of radiation. Now, this stimulated emission, we have to see about, we have to learn about the stimulated emission again. Stimulated emission. This stimulated emission depends on many things. It will not occur always. It will depend on some criteria. What are the criteria? Say, for example, there are 6 electrons in the ground state and 2 electrons in the excited state. Now, one wave will come. H nu is coming. Say, for example, visible light is coming. Now, what it will do? What it will do? Will it knock it, or will this electron will absorb this H nu and will go to the excited state? There are 2 possibilities. By this light can knock this electron to the ground state, can knock out this electron to the ground state, or this light can be absorbed by this electron to go this electron from ground state to excited state. So it can do 2 things. This light can do 2 things. Then what it will do? What this visible light will do? Actually, it depends on the population of the ground state and excited state. That means population of electron. What it will do? It will depend on the population of electrons in both excited and ground state. What incoming light will do, it will depend on the population of electrons in the excited state and in the ground state. What does it mean? If the population of ground state is larger than the excited state, then the probability of absorption of light by the electrons of the ground state will be higher than the stimulated emission. If the population of ground state is larger, population of what? Population of electrons. Then the excited state then the probability of the absorption is higher than the probability of emission. Emission means your what happens? Emission means your stimulated emission. কি হচ্ছে? Emission means stimulated emission. So if this is the case,
sir, ওই লাইনটা উঠাতে পারিনি, আপনার একটু কানেকশনের প্রবলেম হচ্ছিল সেজন্য।
কোন লাইনটা?
স্যার লাস্টে যেটা
স্যার একটা কোশ্চেন ছিল স্যার।
হ্যাঁ বলো।
স্যার আমরা যে লাইটটা দিচ্ছি ওটা তো স্যার ওই যে এক্সাইটেড স্টেট থেকে ইলেকট্রনকে নক করতেছে আপনি নিউট্রাল স্টেটে গ্রাউন্ড স্টেটে। এবং এটা কি স্যার এক্সাইটেড স্টেট থেকে ইলেকট্রনটাকে আরো এক্সাইটেশনে করতে পারবে? আমি
তোমার কথা বুঝি নাই।
মানে এক্সাইটেড স্টেট থেকে যে ইলেকট্রনগুলো নক আউট হচ্ছে, মানে আমরা যে লাইটটা দিচ্ছি ভিজিবল লাইট, এই এনার্জিটা কি স্যার এক্সাইটেড স্টেটের ইলেকট্রনগুলো শোষণ করে আরো উপরে যেতে পারবে?
আরো উপরে এক্সাইটেড স্টেট তো চলে গেছে, এক্সাইটেড স্টেটের উপরে তো কিছু নাই। ইউ হ্যাভ টু স্টেটস, ওয়ান ইজ গ্রাউন্ড স্টেট এন্ড অ্যানাদার ওয়ান ইজ এক্সাইটেড স্টেট। দেয়ার ইজ নো সুপার এক্সাইটেড স্টেট। নক করে এটাকে সুপার স্টেট, এটা নক করে উপর থেকে ঠেলে তোমাকে নিচে ফেলে দেবে। বুঝতে পেরেছো? You have two states. One is ground state, another one is excited state. That means you have two states. One is valence band and another one is conduction band. You have two states. বুঝতে পারছো না? সুপার এক্সাইটেড স্টেট বলে কিছু নাই, এক্সাইটেড বলে কিছু নাই। আচ্ছা, now if this is the case, for example, if this is the case, this is the case, will we get the lasing action? Will we get the laser? Because when this energy will come, it will not knock this electron to here. It will absorb by this electron to go from this state to this state. So if the population of ground states say N1 is greater than N2, if N1 is N2, no laser is found. Will not get any lasing action or no lasing action is found. No lasing action is found. But if this is the case, now we'll get the lasing actions theoretically, because what? Because this energy will knock this electron out to the ground state. ঠিক আছে? What is stimulated emission? We got it.
লেখাটা দেখা যাচ্ছে না।
এরপর it is. ঠিক আছে? Now Boltzmann distribution law পড়েছো তোমরা? Boltzmann distribution law in physical chemistry. তোমরা পড়ো নাই Boltzmann distribution law? নাকি ছিল না, ইম্পর্টেন্ট ছিল না? পড়ছিলা? মনে নাই। এইগুলো আসলে তোমাদেরকে পড়ানো হয় কিসের জন্য? তো তাড়াতাড়ি ভুলে গেলে তোমাদেরকে পড়ানো হয় কিসের জন্য? হ্যাঁ, তো মহা মুশকিলের মামলা। হ্যাঁ, পড়ছিলাম Boltzmann distribution law। আচ্ছা, মনে নাই। আমি তোমাকে আই এম নট আস্কিং ইউ অ্যাবাউট দ্য ল, আই এম নট আস্কিং ইউ দ্য ল, বাট হোয়াট ইজ ইট ফর? Boltzmann distribution lawটা কিসের জন্য দিয়েছিল মনে আছে?
Distribution of energies of molecules, sir.
হ্যাঁ, distribution of energies of molecules. That means distribution of electrons in the excited state and in the ground state. Of course, the energy of the electrons in the excited state is higher than the energies of electron in the ground state. So, according to Boltzmann distribution law, the distribution of electrons in the ground state and excited state, this condition cannot possible. It cannot be in the excited state more electron than in the ground state. It cannot be possible. It cannot be possible in the excited state more electron than in the ground state. The highest what will happen? The highest N1 is equal to N2. That means if there are 5 electrons in the ground state, there will be 5 electrons in the excited state. That is the highest. That is called saturation. That is the highest. Normally, what happens? The number of electrons in the ground state is larger than the number of electrons in the excited state. But this condition, this condition is called inversion population. That is very important term, inversion population. Population. What it is? The number of electron in the excited state is higher than in the ground state. If this condition occurs, it is called inversion population. So why it is inversion population? In the normal population, the number of electrons in the ground state is larger than in the excited state. It is normal population. But if it is inversion, then the number of electrons in the excited state will be larger than in the number of electrons in the ground state. But according to Boltzmann, in a two-state system means one is excited state, another one is ground state. In a two-state system, an inversion population is not possible. But without inversion population, lasing action is not possible. That means you cannot find laser without inversion population. Without inversion population, possible. But according to Boltzmann, in a two-step process, laser is not possible, because in a two-step process, inversion population is not possible. For that, in a two-step process, laser is not possible. For this reason, although Einstein established about the stimulated emission of radiation at 1915, we did not get laser till 1960 or 62 or 63. For this reason only. Now, how we can get laser? So we must have a third layer. we must have a third state. This is ground state. Say, for example, this is ground state. And this is excited state. And in between this, we must have a third state. Now, what is that third state? What is its criteria? This third state is known as metastable state. Metastable states. Some substances like chromium has this type of a metastable state. What happens in this metastable state? Electrons from the ground state, it goes to the excited state. It goes to the excited state. Okay. And this electron will stay here, say for example, about 10 to the power minus 12 second will stay here, and it will come to this state. It will come to this state by non-radiative emission. It will come to this state by non-radiative emission. What does it mean, non-radiative emission? This is radiation. Say for example, this is radiation. We are getting a wave. Say if it is in the visible region, so we will see the color. But it is a non-radiative emission. So in this case, this wave is not found. This type of wave is not found. So what will found? Say for example, it emits energy as heat. We call it phonon. Phonon, phonon. And for this wave, we call it photon. The non-radiative emission is known as phonon, and the radiative emission, that is light, is known as photon. So it comes here, and in this state, it stays more time than here, than in excited state. It stays about 10 to the power 9 seconds here. It stays about 10 to the power 9 seconds here. So it stays, this electron goes to the excited state. It stays 10 to the power minus 12 seconds here. Then not by returning in the ground state, it returns to a metastable state and stays here about 10 to the power minus 9 seconds, 1,000 times greater than your excited state. Within this time, more electron will be excited to the excited state. For that region, we can get the population inversion. we can get the population inversion. জিনিসটা বুঝতে পেরেছ? How we get population inversion? হ্যালো, শুনতে পাচ্ছ তোমরা?
Yes, sir.
এখানে আমার এখানে মধ্যে ইন্টারনেটটা হঠাৎ করে একটু স্লো হয়ে গেছে, তাই না? ক্যামেরাটা দেখতে এখন দেখতে পাচ্ছ? শোনা যাচ্ছে আমার কথা? আচ্ছা, ভেরি গুড। তোমরা কি বুঝতে পেরেছো how it is how we can get population inversion? কি হয়েছে দেখো, এখান থেকে ধরো 4টা ইলেকট্রন উপরে উঠেছে, then this instead of this 4 electron coming towards ground state, it comes to that metastable state and it stays 1,000 times more than in the excited state. বুঝেছ? এটা এখান থেকে এইখানে চলে আসে, এইখানে না আসে। এবং এখানে this metastable state, তার staying capacity is 10 to the power minus 9 second, 1,000 times more than the excited state. তাহলে সে এখানে অনেকক্ষণ বসে থাকে। In the meantime, more electron goes to the excited state from the ground state. ধরো in the meantime আরো 4টা ইলেকট্রন excited state এ চলে গেল। This 4 electron goes to the excited state. Now there are 2 electrons and this goes to the excited state and this comes to the metastable state immediately. Now there are 2 electrons here and 8 electrons here. So it becomes now a population inversion between, say for example, N1, it is N2 and it is N3. So N3 is greater than N1. So number of your electrons in the metastable state is higher than the ground state. Now you can have the lasing action. If one electron, if one wave knocks this towards here, then you will get the lasing action. The lasing action starts. The lasing action starts. So in a 3-step process, laser can be possible. Three step kiki. What are those 3 steps? One is excited state. Sorry, one is ground state. Second one is excited state. And third one is metastable state. So, what are the conditions? First condition for a laser action, the system must have 3 states. Second, the time duration in metastable state must be higher than the excited state for an electron. Time duration of a state, the time in metastable state must be higher than the excited state for an electron. Okay? Sharabo? Now, third হচ্ছে the transition from the excited state to the metastable state must be non-radiative and fourth condition, the transition from the metastable state to the ground state must be radiative. তোমরা 4টা কন্ডিশন পড়ো তো, 4টা কন্ডিশন বুঝছো কিনা? এটা দেখেছো, এটা বুঝেছো ফিগারটা? If all these conditions are fulfilled, then inversion population occurs and we can find light amplification by stimulated emission. Now what will happen? You see, the most of the electrons from the ground state, goes to the excited state and then to the metastable state. Then from the metastable state, all of the electron will come to your ground state again. All of electron will come to the ground state again by giving a laser light. So ultimately what will happen? All these electrons will come to the ground state and you have to give another light and this electron will go again to the upper state and will come to the state, then you will get again a laser. So it is not a continuous process. Is it a continuous process? It is not a continuous process. Electrons are going here, then coming here. We are getting laser. Why? Because these electrons of the metastable state is coming to the ground state. And when this electron comes to the ground state, again inversion population is lost. So when inversion population is lost, we are not getting laser. When you get laser, again when a light falls on this electron, when this electrons will go here, when this comes here, and when it comes here, then we will get again laser. So this type of laser is not a continuous laser. It is not continuous. It is pulsed. It is pulsed. Once I get one, then a brief pause, and then we get again one, and then stop, and then again one, and then stop. This is pulsed laser. So for this system, we get pulsed laser. For this system, we get pulsed laser. What is the pulsed laser? One light, we get one light, then stop. Again get one light, then it is again stop, and get one light, again it is stopped. So to get the continuous laser, this three-state system, by this three-state system, we shall not get any continuous laser. We shall get a pulsed laser. So for the continuous laser, we must have a four-state system. Now this is this is ground state. This is excited state. These two are metastable states. Now, what are the conditions here? What are the conditions here? This transition from this state to this state is non-radiative. And from this state to this state, it is also non-radiative. And this state, this transition is radiative. This transition is radiative. This is non-radiative and rather quick. You see, okay, quick. And it is also quick from here to here. It is also quick. But this is a slow transition. This is a slow transition. So what will happen? Electrons from here, it will go towards, say for example here, it goes from here to here, immediately it comes here. Immediately it comes here. Now you see, there is no electron. You see, in this state, there is no electron. And in this state, there are 4 electrons. So this is a inversion population. Here, inversion population happens. In the ground state, there are no electrons. But in the excited state, you will find 4 electrons. So inversion population happening here. And you will get laser from here. And when it comes here, immediately this electron will come here. And again it will go here, it will come here, immediately it come here. And this process is first. Which processes? This process, this process, this process is first. And this process is slow. For this, the time for this process is higher, and the time for this whole process is slower. Say, for example, the time for this process is 5 seconds, and the time for this whole process is 4 seconds. So what will happen? We will get constant electron here. And if we will get 1 electron here, then it is inversely populated, because there is no electrons. When electron comes here, it immediately comes here. If you get only 1 electron, or if you get only 2 electrons here, this system is inversely populated, because this state is empty. And this system is actually laser forming system. You will get laser here, from here. So it becomes a continuous, and you will get continuous laser. You will get continuous laser. So what is the conditions? What are the conditions? The condition is that from excited state to first metastable state, it is quick. Then first metastable state to second metastable state is slow and radiative. And from the second metastable state to the ground state is again very fast and non-radiative. This is the four stage system, and you will get continuous laser from this. You will get continuous laser from this. এটা বুঝতে পেরেছো? কারো কোথাও কোনো সমস্যা আছে? বলো তো আমাকে, কোথাও বুঝতে না পারলে আমাকে একটু বলো তো। কোথাও যদি বুঝতে না পারো আমাকে বলো। যে কিভাবে এটা কন্টিনিউয়াস হচ্ছে। কন্টিনিউয়াস হচ্ছে তার কারণ হচ্ছে এই স্টেটে, ইন দিস স্টেট, মেটাস্টেবল স্টেট, এখানে কোনো ইলেকট্রনই থাকছে না, যার ফলে এই সিস্টেমটা অলওয়েজ তোমার ইনভার্সলি পপুলেটেড হচ্ছে। উপরের স্টেটে একটা ইলেকট্রনও যদি থাকে, ইট ইজ ইনভার্সলি পপুলেটেড হচ্ছে, যেটা তোমার এইখানে হচ্ছে না। এখানে ইনভার্সলি পপুলেটেড হতে হলে আগে উপরে ইলেকট্রন উঠতে হবে, তারপরে এখানে আসতে হবে, এবং ইলেকট্রন বেশি করে উঠতে হবে। একটা দুটো উঠলে হবে না, বেশি করে উঠতে হবে। এখানে একটা দুটো করে উঠলেই হয়ে যাবে। এখানে যদি দুইটা ইলেকট্রন ওঠে, then it will come here and this is inversely populated, তখন তুমি এটাকে তুমি you're getting laser, you are getting laser. So not every substances, not every light absorbing substances will not give you laser action. প্রত্যেকটা লাইট অ্যাবজর্বিং সাবস্টেন্স তোমাকে লেজার অ্যাকশন দেবে না। লাইট অনেকেই অ্যাবজর্ব করে, লাইট অনেকেই অ্যাবজর্ব করে, বাট দে উইল নট গিভ ইউ লেজার অ্যাকশন because you have to have what? You have to have some metastable states. Not every particle have metastable states. Now there are another type of lasers. They are called semiconductor lasers. It is very simple. It is very simple. Your valence band and it is your conduction band. So in the conduction band there are free electrons. Say these are the electrons, these are the electrons, free electrons, and these are the holes, and say these are the holes. So if you can knock this electron to the hole, if you can knock this electron to the hole, then you will get laser. Very simple thing. How you can knock this electron? Because if you connect this with a battery by forward biased, then this is negative charge and this is positive charge, then this will knock you, this will repel this electron to the hole, and you will get lasing action just like diode. Just like diode. আমি যে পয়েন্টটা দিয়ে কাজ করতাম, যে পয়েন্টটা দিয়ে তোমাদেরকে দেখাতাম, that is a semiconductor. Semiconductor laser is very cheap and very simple. দেখো তোমাকে এখানে ইজিলি তোমাকে আমি দেখিয়ে দিলাম. It is very simple. If you have a PN junction and if you connect it forward biased, then the electrons will be knocked, will be pushed to the hole, and when it joined to the hole, it emits your light, and we will get it as laser. This is the fundamental principle of laser. Now we shall see some particular lasers. We shall see some particular lasers. Now, if you see the slides, operation of lasers involves population inversion of energy state process. Now you know what is population inversion and what is energy state process. You know it now. Now next section, what is population inversion? What happens, say in the chromium, this is the ground state and this is the excited state, and the transition from the ground state to the excited state is known as pumping. The transition of electron from lower state to higher state is known as pumping. You can pump, you can transit from lower state to higher state by various ways, by giving light or by electrical discharge, in various ways. You can pump from lower state to higher state. Then a non-radiative spontaneous decay, which is called phononemation, to the metastable state. It is in case of chromium, and from this metastable state, this is radiative emission, and we are getting laser photon or laser light. And I told you that this is a pulsed laser. This is a pulsed laser. So actually, this type of laser, this type of pulsed laser is done by ruby. Ruby is actually, I think, it is made of aluminum chloride or aluminum something. What is aluminum chloride? It's an aluminum salt, and it has some impurities as chromium. Ruby is a single crystal of an aluminum salt, and it has some impurities. It has some impurities of chromium. This chromium shows the laser action in ruby. What happens? You say this is the, you see, this is the ruby. This is the ruby crystal, and this is a xenon lamp, flash lamp. Why this flash lamp? This flash lamp is for to pump the electron from the ground state to excited state. By giving this flash lamp, by giving light to the ruby, in the ruby there are chromium. The electrons from chromium goes from the excited state to the ground state and then comes to the metastable state. And when it backs from the metastable state, you will get a coherent beam of light. Now, what is the theory behind it? What is the theory behind it? You see, there are, say for example, if we draw a picture again, if we draw a picture again, say for example, this is a cavity from where laser will be out. This end is polished, and this end is partially polished. Here there is an opening, so this end is partially polished. It is polished by actually silver. So say for example, this is a ruby crystal, this is a ruby crystal, and this is the flash lamp, and it is joined. It is joined here in the battery. It's joined the battery. This is a ruby crystal. So when you give charge to this flash lamp, light emits. What light will do? The light will pump electrons from the ground state to excited state, and the electron will come from excited state to metastable state. Say this is by this, and again this will come here and it will give your laser. Now what will happen? Here it will give the laser, it will go here, go here, go here, and then return back. Go to this, and then return back. Because these are polished, it will return back. This will be returned back. Return back, and on this way, it will get more and more waves. On this returning, it will get more and more waves. Say for example, here it is 3. Then when it will come here again, then it will get again 7 or 8. Because more and more it is going up and down, up and down, up and down, and you will get more and more waves. You will get more and more waves. And when it comes necessary, then you open this. You open this and laser will go through this way pointedly. Why it is pointed? Because all the waves are in same manner. For that laser is pointed. And the strength of laser depends on how many times it goes from here to here, from here to here, how many times it passing through this. So this is the semiconductor. This is the your laser action. This is your laser action, and so you see, at first there are two or three lights. Say this 3 is coming here, and here it is increasing, and from here you see more and more you'll get. But this is very much pointed. This is very much pointed because they all have same frequency. So they are pointed. The laser is pointed. Now this is a semiconductor. So this is an example of pulsed laser. I have told you what are pulsed lasers. Now this is the semiconductor laser. Semiconductor laser is actually PN junction. You see this is P. This side is P, and this side is N, and here is the junction. I told you how it works. It's actually electron plus hole, neutral ground state, energy. Recombination of an electron hole pair generates a photon of laser light. This is the laser. এখন আমাকে বলো কার কোথায় সমস্যা আছে? কারো কোনো কোশ্চেন? বলো। কারো কোনো কোশ্চেন? বলো। তোমাদের লেজার নিয়ে পুরা একটা 1.5 ঘন্টার ক্লাস নিলাম। ফিজিক্স ডিপার্টমেন্টও নেয় না, এগুলো হচ্ছে ফিজিক্সের মামলা, পুরাটাই ফিজিক্স, পুরাটাই ফিজিক্স। এখন না বুঝে থাকলে, কোথাও যদি না বুঝে থাকো আমাকে বলো। আদারওয়াইজ পরে প্রবলেমে পড়ে যাবে। সবাই বুঝেছ? সবাই বুঝে থাকলে আই এম সাকসেসফুল, কারণ এটা খুব কঠিন জিনিস। এটা বোঝা এত সহজ ব্যাপার না, এটা বোঝা এত সহজ ব্যাপার না। এটা হচ্ছে একটা কথা। তার চেয়েও কঠিন হচ্ছে বুঝে মনে রাখাটা। আমি যে এইগুলো বুঝলাম, পপুলেশন ইনভার্সন, এই সেই, থ্রি স্টেজ, 2 স্টেজ, 4 স্টেজ, সেমিকন্ডাক্টর লেজার, হ্যাঁ, এই এতগুলো যে বুঝলাম, উইদিন 1 উইক আমি কিন্তু ভুলে যাব। সো আমাকে এগুলোকে প্রিপেয়ার করে এখনই রেডি করে ফেলতে হবে। এভরিথিং অ্যাকচুয়ালি আমি যা যা এর আগেও পড়িয়েছি, হ্যাঁ, উইদিন 1 উইক আমি কিন্তু ভুলে যাব যদি আমি এগুলো না পড়ি। তখন পরীক্ষার হলে মনে হবে, ধর এটা কোথা থেকে কি আসলো, স্যারে এখান থেকে দিছে, ওইখান থেকে দিল না কেন, হ্যাঁ, এইগুলো আবার শুরু হবে যে সেমিকন্ডাক্টর দেয় নাই স্যারে, ফলে পারলাম না, হ্যাঁ, এই সমস্ত শুরু হয়ে যাবে।
স্যার একটা কোশ্চেন ছিল স্যার।
হ্যাঁ বলো।
স্যার ওই ম্যাটাস্টেবল স্টেটটা তো স্যার বলছেন সবগুলা অ্যাটম দেখাবে না, মানে কোনগুলা দেখাবে এটা বোঝার
হ্যাঁ
কি?
হ্যাঁ হ্যাঁ, ওই যে তোমাকে বললাম একটা 3 স্টেজ লেজার জেনারেলি ক্রোমিয়াম দেখায়, হ্যাঁ, তারপরে 4 স্টেজ যেগুলো, সেগুলো অ্যাকচুয়ালি বিজ্ঞানীরা বানায়, হ্যাঁ। একটা আছে নিওডাইমিয়াম, ইট্রিয়াম, গ্যালিয়াম দিয়ে একটা বানিয়েছে, হ্যাঁ, দ্যাট ইজ 4 স্টেজ। এগুলো বিজ্ঞানীরা বানায় 4 স্টেজ লেজার গুলো, কম্পাউন্ড গুলো একটার সাথে একটা, একটার সাথে একটা, একটার সাথে একটা মিক্স করে এগুলো বানায় আর কি, হ্যাঁ। তুমি আমরা জেনারেলি ফার্স্ট লেজার পাই রুবি লেজার। রুবি হচ্ছে আমরা অটোমেটিক্যালি থেকে পাই, খনি থেকে পাই, দ্যাট ইজ এ সিঙ্গেল ক্রিস্টাল। তার ভেতরে ক্রোমিয়াম অটোমেটিক্যালি ইম্পিউরিটি থাকে। ফর দিস ক্রোমিয়াম দি কালার অফ রুবি ইজ রেড, হ্যাঁ। সো ওইটা থেকে আমরা ফার্স্ট লেজার আমরা পাই ফ্রম রুবি। পরবর্তীতে লেজারগুলো বিজ্ঞানীরা লেজার বানানোর জন্য যে মিডিয়াম গুলো, অ্যাকচুয়ালি ওই মিডিয়াম গুলো বিজ্ঞানীরা বসে বসে বানায়। তুমি ইন্টারনেটে তুমি সার্চ করো, দেখবে অনেক রকমের পেয়ে যাচ্ছ, বেশ ফানি ফানি কতগুলো কম্পাউন্ড, হ্যাঁ, বাট দে আর ওয়ার্কিং, হ্যাঁ, দে আর ওয়ার্কিং। ইউ ক্যান হ্যাভ গ্যাস লেজার্স অলসো, আর্গন লেজার, অমুক লেজার, এগুলো গ্যাস লেজার অলসো। তুমি গ্যাস লেজারও পেতে পারো, গ্যাস থেকেও পেতে পারো। অ্যাকচুয়ালি গ্যাস থেকে পেতে সমস্যা কি? তোমার প্রবলেমটা হচ্ছে ইলেকট্রন এক্সাইটেশনটা অ্যান্ড ইলেকট্রন ট্রানজিশন ফ্রম দ্য মেটাস্টেবল স্টেট, হ্যাঁ, ইট ইজ দ্য প্রবলেম। সেটা গ্যাসের থাক, সেটা সলিডের থাক, ইউ ক্যান গেট দ্য লেজার। আর কারো কোনো কোশ্চেন আছে? নাই, ঠিক আছে, রোল কলটা করি। 4 লাবিবা আছে, লাবিবা নাই আজকে। 7, 15,
Yes, sir.
18, 71, Hafsa, Sabbir.
Yes, sir. Yes, sir.
Sabbir, 72, Abhijit.
Yes,
80.
sir. Yes, sir.
Abhijit, na?
Yes, sir.
82, Arif.
Yes, sir.
90, Rajia.
Yes, sir.
95, Mim.
Present, sir.
96, Banias. 96, Banias.
Yes, sir.
97, Shoban.
Sir.
Shoban aso? 100, Amjad. 106, Pranto.
Yes, sir.
111, Pranto. Tao
Yes, sir.
Pranto. 114, Rakib.
Yes, sir.
120, Kamrul.
Yes, sir.
121 Arif.
Yes, sir.
124 Morshed. 125 Abu Hena.
Yes, sir.
26 Nandita.
Yes, sir.
128 Shuman.
Yes, sir.
129 Abu Saleh.
Yes, sir.
131 Manjur Elahi. 134 Saidul Islam Majumdar.
Yes, sir.
136 Azad.
Yes, sir.
142 Nafisa.
Present, sir.
148 Rafiul.
Yes, sir.
156 Shirajul.
Yes, sir. Sir, একটা কথা
শেষ করি আগে রোল কল শেষ করি 116 Asma. 128 Anis.
Yes, sir.
131 Shamim. 74 Ahmed Al Hajjaz. 84 Rubel Mia. 65 Halimur Rashid. কেউ বাকি আছো? ওকে, কি কথা তোমার বলো?
স্যার গতকাল ক্লাসে করছিলাম স্যার এই
ওরে সর্বনাশ, গতকাল ক্লাস করছিলা, আজকে আমি মনে রাখতে পারি নাই।
না স্যার অ্যাটেন্ডেন্স দেওয়ার আগে কারেন্ট চলে গেছিল তো স্যার আর কানেক্ট করতে পারি নাই।
আর কানেক্ট করতে পারো নাই, এখন আর কিছু করার নাই। আমি একটা কাজ করতে পারি, এখন থেকে তোমাদের একটা স্ক্রিনশট নিয়ে রাখতে পারি। দ্যাটস গুড। আচ্ছা, তোমার তো ভিডিওই আছে আমার কাছে, আমি দেখবো, ভিডিও দেখে তোমাকে আমি ইয়ে দিয়ে দেবো।
জি স্যার।
হুম।